It's a pleasure being here. This is the first such meeting I've attended, and it's a little bit strange. Jane emailed me some months ago, and I realized this summer I was going to be in the States, so I said yes. And I was curious as to what Doctors for Disaster Preparedness was. I'm still not totally sure, but it's an interesting collection of people who, I've found listening today are terribly informed, and not meaning badly informed, but much informed, and also concerned about some of the same things that I am. I've been impressed with the presentations. Their quality is much better than my usual quality of presentation. And I usually associate good presentations with the wish to sell something. And I'm not sure, because the audience here seems not to be buying anything particular. So, Now, Jane asked me, what would I speak on, global warming. She said I could think of a more interesting title. So I glibly thought of a title like this. And then as I was preparing the talk, I realized I really hadn't thought through what one could say on this topic. And so this is going to be a slightly ad hoc talk, but it's a topic, as always, that if one takes it seriously, is much more than can be covered. So I'll take the usual route and speak for a relatively short time and leave it open to questions. Okay, the first thing when talking about science in the public is to remember that science is always problematic when referred to as an institution. Where it's valuable is as a process. Now, I'm always charmed. There was a wonderful biography of Darwin that came out. What is the woman's name? Come back to me. But it's described how Darwin often expressed gratitude for being able to be a gentleman scientist with no need for institutional affiliation. And he was comparing himself to colleagues, Huxley and so on, who had the problem of dealing with universities. Now, unfortunately, as a practical matter, the gentleman scientist no longer exists. Even in the 19th century, most scientists needed institutional homes, and today science almost inevitably requires outside funding. And in some fields, including climate, the government has essentially a monopoly on such funding. Now, at institutions, expanded funding is always eagerly sought, but it inevitably also invites rent-seeking by scientists, university administration, and government bureaucracies. One of the largest growth areas are the funding agency's own staff. At any rate, this has been discussed in detail. You don't need me to describe it, and even to the extent I've discussed it, it's only among many other people. There's a very interesting book by Dan Greenberg that came out in 2001. It's hard for me to believe this is already a dozen years ago, called Science, Money, and Politics, Political Triumph and Ethical Erosion. Dan Greenberg probably, as journalist goes, has followed science as an institution more closely and knowledgeably than almost anyone I know. He was a long-term editor of Science magazine. He was then the science editor at the Washington Post. And since many years, he's been sort of a freelancer, largely, I think, because his cynicism about the whole thing had gotten to the point where the Washington Post couldn't deal with it. Now, even then, Science, Money, and Politics is a serious book. And in a serious book, you often cannot express yourself quite the way you would like to. So he did, a couple of years ago, come out with a fictional account of the same stuff in a book called Tech Transfer. Tech Transfer is not the best written novel I know, but it is funny and describes how the institutions work. A different kind of book on a similar subject, and I'll come back to it, is a book in 1969 by a then Soviet scientist, Zhoresh Medvedev, called The Rise and Fall of T.D. Lysenko. And that's a moving and interesting book about how a science in the public square got completely distorted, and also how it got corrected, which is of interest. I had an article a few years ago, it has 2 dates on it, because it was delayed ad nauseum, and so I originally put it on a website called Archive. It's called Climate Science, Is It Designed to Answer Questions? And it also describes the institutional issues. It has recently appeared in something called the Eurosys Journal, and it's available from me. There was an article I wrote in 1996 on Science and Politics, Global Warming in Eugenics, and it appeared in a book called Risks, Costs, and Lives Saved by Bob Hahn. And that's available, and so is the article. And then now, currently in press, is a book by the chess master Garry Kasparov, together with Levchin and Thiel. Thiel is a multi-billionaire inventor of PayPal, called The Blueprint. And it is, again, discussing the structural problems in science and why something that bothers them particularly, science in terms of fundamental inventions seems to have dried up since the 60s. Okay, so that's your reading if you're interested in this general topic. All of it involves science in the public square, but the public square brings its own dynamic into the process. And I'll emphasize how this plays out in the climate issue, but there are 2 other areas where I'll come back to it, and one is the issue of eugenics and immigration and Lysenkoism in agronomy, where you had, again, science in the public square. There are lots of reasons why scientists, for publicity and other things, might want to bring their field into the public square. But in the cases I'll describe, these are cases where it was the political agendas that found it useful to employ science. And this immediately involves a distortion of science at a very basic level. Namely, science becomes a source of authority rather than a mode of inquiry. And the real utility of science stems from the latter. The political utility stems from the former. And it's a really profound distinction. For science to be politically useful, there appear to be several requirements. And this I listed in the paper on eugenics and global warming. You need powerful advocacy groups claiming to represent both science and the public in the name of morality and superior wisdom. And with global warming, it's the environmental movement. You need simplistic, by the way, I should mention at the beginning of the 20th century, the counterpart of the environmental movement was eugenics. All the best people displayed their virtue by supporting that. You also needed simplistic depictions of the underlying science so as to facilitate widespread, and I put in quotes, understanding. And this is a very serious issue, and I'll come back to it. You need events, real or contrived, interpreted in such a manner as to promote a sense of urgency in the public at large, which is necessary to promote the agenda. So with eugenics, it was a contrived issue. The issue was immigration. That was the publicly important issue. The event was, in World War I, the intelligence tests given to the draftees demonstrating that there was an epidemic of feeble-mindedness that was attributed to immigrants from Southern and Eastern Europe. And so there was a need for immigration restriction. Scientists, flattered by public attention, including financial support, and deferent to political will and popular assessment of virtue, are essential to the process. And of course, there will be significant numbers of scientists eager to produce the science demanded by the public. So you invert the whole process of inquiry. These conditions are not independent, and they interact in important ways. So, for instance, the media thrive on scare stories. This is an old cartoon. It's cute. The networks need a lead story to scare everyone. Whose turn is it to pick a noun? And then, global warming, whatever you need. Scientists can benefit without committing themselves. This is an old cartoon I generated maybe 10 years ago. Called it The Sad Tale of the Iron Triangle and the Iron Rice Bowl. Scientists make meaningless and ambiguous statements. The advocates and media translate statements into alarmist declarations. The politicians respond to alarm by feeding scientists more money, and the whole thing goes on and on and on. Okay, scientists far from climate are encouraged to get a piece of the action. Somebody listed this as, collect $200, pass go. Here are some examples I loved, and if you're an academic, you realize these sums are sizable. Psychology, quote, climate change, this is part of the abstract for the proposal that got funded. Climate change represents a moral challenge to humanity and one that elicits high level of emotion. This project examines how emotions and morality influence how people send and receive messages about climate change, and does so with an eye to developing concrete and doable strategies for positive change. That got 200K. And it's part of NSF's big mobilization. They're spending quite a lot of money to find out why people aren't buying the alarm. And this harkens back to my personal attitude. Ordinary people have sense. Academics don't. Political science is another topic that's gotten into the wagon. This one really impresses me. It says, common sense says that claims about how social and political life ought to be arranged must not make infeasible demands. This project will investigate this piece of common sense and explore its implications for a number of pressing issues such as climate change, multiculturalism, political participation, inequality, historical justice, and the rules of war. They got 400K for that. Okay, what are the consequences of this situation? Well, first of all, the public inability to judge science inevitably leads to ascendancy of politically correct mediocrities or incompetence. And that's something I don't even want to be quoted on, but it's perfectly obvious in all these issues. Lysenko was not an evil man, I would argue, and I don't think Medvedev would. He was a reasonably mediocre to incompetent agronomer who resented the fact that that's how he was regarded, and given the opportunity to be a leading figure, he leapt for it without any concern for the consequences, which were millions dead from agricultural failures. guy called Harry Laughlin was essentially a lab assistant, administrative assistant at Cold Springs. He did have a PhD, but he was nowhere on the totem pole. Eugenics gave him the opportunity to be Congress's leading expert on human genetics. This was something. Eventually, he was rewarded by an honorary degree in the 1930s from Heidelberg. In our field, people like Michael Mann, Phil Jones, and so on, Phil Jones in particular, I'm not even terribly critical of him, but within climate science, I mean, I should mention an obvious fact. In 1990 at MIT, no one in oceanography or meteorology referred to themselves as a climatologist. Climatology was used to refer to state record keepers. And it was a lowly position, underappreciated in many respects. But all of a sudden, this issue allowed people who were in the corner office doing the work no one else wanted to do to become leading scientists. Now, this, first of all, gives them a status that they will cling to. It's obvious. I mean, this now makes their lives worthwhile, and this will come up in a number of respects. And unfortunately, it also induces better scientists to join the pack in order to preserve their status. And in the UK, this is particularly obvious. All sorts of people who were skeptical for years joined the bandwagon and got immense promotions and chairs and so on. Now, we saw in that iron triangle thing that advocates grossly exaggerate results in order to promote their cause. And this happens on all sides of the issue. 2 weeks ago, next to the last issue of Weekly Standard, has a great description of this, dealing with the Witherspoon Foundation and a sociologist called Regnerus. He did a study for Witherspoon on the impact of gay parentage on children's development. Hot topic, you know, marriage, so on. Political issue. The paper itself was extremely qualified. It pointed out all its own defects. It couldn't get a large sample, even though it started with a large one. It was very circumspect. Witherspoon advertised it as proof that defense of marriage was essential. This is always a danger with these issues, and as I say, on all sides. The other thing that it leads to is an obsessive focus on unimportant or irrelevant aspects of the issue, because somehow the public can grab onto these. And this, in turn, leads to a profound dumbing down of the discussion, including the abdication of logic. And that, in turn, interacts with the ascendancy of incompetence. Okay, here's an example of the illogic. In 2003, the environmental writer for The New Yorker, certainly a flagship periodical of bien-pensants, the thinking people. Here's her statement on it, and I guess it's her fix on science. All that the theory of global warming says is that if you increase the concentration of greenhouse gases in the atmosphere, you will also increase the Earth's average temperature. It is indisputable that we've increased greenhouse gas concentrations in the air as a result of human activity, and it's also indisputable that over the last few decades, average global temperatures have gone up. So, for her, as for Naomi Oreskes and others, this is indicative of science at its best. For this misreading of scientific logic, she received prizes and accolades. This, of course, is a huge topic, but here I'd like to focus on one matter: the very notion of globally and annually average temperature anomaly as a unique metric of climate. Now, we've had a lot of discussion here on this, and I'm going to be somewhat critical of that discussion in general. Here's the graph that is perhaps the most famous graph in contemporary climate. This is the variation of Earth's surface temperature. This has to be from the Hadley Center past 140 years. I didn't take the more recent one, which was the next graph on it. And, you know, we've been looking at this, one discusses this, so on. This becomes the definition of global warming, so on. Many of us, including me, including good scientists, have spent many pages discussing and analyzing various aspects of this graph and dissecting the numerous adjustments needed to produce it. Why? Well, we'll come to discuss that for a while. I think it may be because people are always pontificating about similar-looking graphs. This was in an ad that was appearing, and this is a totally different time scale. This is 1 year, but we're used to looking at graphs that have, you know, a shape. Indeed, if I change the time scale, it's indistinguishable from what we look at in climate. And as you notice, I mean, when it's stock prices, you have somebody who will explain every single detail of it with somehow, as we all know, no predictive capacity, whatever. To what extent is globally and annually average temperature anomaly a meaningful metric of climate? Well, here is a graph that I worked out from some tables that had been produced many years ago by two then Soviet climatologists, Budiko and Israel. And Israel is still alive. Budiko died a couple of years ago. They weren't knowledgeable people, and they had studied climate changes over all time scales, ranging back millions of years to contemporary changes, 1940 and so on. And what they suggested is that all the changes you saw could be plotted sort of in this fashion. And what you're seeing here is, try and understand this. This is latitude, if I can point this out. So here, it's actually sine of latitude that we're showing. And here is temperature, but it's actually the change of temperature at a given latitude divided by the change in the global mean, okay? And here is the global mean, so for this purpose we take it 1, but if you had a global mean of 2, you'd change everything along this curve. At the equator, there is between nothing and a little change, so you have all the change occurring outside. What the mean is the residual that comes from the fact that you've changed the equator to pole temperature difference and you've held it reasonably fixed at the equator. So in doing this, you had to change the mean. The mean, therefore, is essentially a residue of the climate change. And in general, residues are not what drive the phenomenon. They're what's left over when the phenomenon occurs. Now, probably the best example of such a changing climate, although by no means the only one, Budiko and Israel maintained all climate changes they looked at followed this, is the Eocene. The Eocene was 50 million years ago, and not surprisingly, I mean, you don't have that much data, but you have cores, deep sea sediments, and so on. And in a paper in 1981 by Shackleton and Bersma, They pointed out that during the Eocene, according to their proxy data, the equator to pole temperature difference was very different from today's. This would be today's temperature distribution with latitude. The pole to equator temperature difference had reduced immensely, and they found that the temperature at the equator had actually cooled. Okay. Now, there then proceeded to occur a huge number of papers that mostly focused on this. Now, my initial instinct was, correctly or incorrectly, that made a bit of sense. You reduce the equator to pole temperature difference by a heat flux to the pole. So you're taking the flux out of the tropics, you're bringing it to the pole, you're going to cool at the equator and warm at the poles. So I didn't find this particularly astonishing. But, oh, and here I have a problem. Can you see the kind of blue here? That's a little bit faint. But what happened over the subsequent years, this is from 2001, is you had immense efforts in the geochemistry community and the paleo community to bring the temperatures at the equator up. And they managed, by looking at genetics and so on of the thing, to argue it might be close to the present, maybe a little more. Why were they doing that? Well, they're doing that because the first attempts to explain the Eocene involved using general circulation models and cranking up CO2. And so you had papers by Eric Barron, Warren Washington, and so on. And Eric Barron made his career on that. They cranked up the CO2. So here is modern sea surface temperature. Here is the model attempt to model the Eocene by cranking up CO2. And here are the range of proxy estimates of Eocene temperature, which now had somewhat reduced the change in pole to equator temperature difference, but still that was the major feature. And what happened is, and this is quite remarkable, you always found, counter to what you'd think from reading the IPCC, that the models, when you cranked up CO2, did nothing to change the equator to pole temperature difference. And so you still had this major discrepancy. And it's still argued you have that discrepancy, although I think we have a good idea why. Nevertheless, the model somehow failed. And you know what this is suggesting is simply trying to change the mean temperature did not produce the Eocene. It just increased the temperature every place. The important takeaway point from this is the Eocene and all climate described by the Boudico-Israel curve are not due to global forcing. The change in mean temperature does not represent sensitivity to global forcing in these cases. Now let's get back to this temperature curve. I mean, you know, what you have here is, it's crucial to look at the vertical axis. You know, this is minus 0.5 degrees, 0, plus 0.5. There is the statistical scatter in the data, which is represented by this fuzz, but it doesn't include systematic errors from instrumentation, interpretation, and so on. So it's pretty big. And it's clear, you know, you're dealing with something that's pretty noisy and uncertain in this. If you continue, that one only continued until 2000 or so. This is the thing that, you know, people have been talking about, that in recent years, hard to tell if there's anything statistically significant happening. On the other hand, the media discussion is kind of cute. The BBC dealing with the fact that the temperature was going no place. Skeptics disagree. They insisted it's unlikely that temperatures will reach the dizzy heights of 1998 until 2030 at the earliest. This is the dizzy height. It's approximately 0.8 degrees beyond that. I don't know. I mean, do people look at numbers in newspapers? I have no idea. Anyway, but let's see what went into this sausage. This is actually an old paper, old piece of work by someone called Stan Grotch at Lawrence Livermore. He died, and nobody has ever replicated this, and it wouldn't be hard to do. It's just always on the back burner. What he did was he plotted all the points that went into the mean. So these are the deviations of annual mean temperatures from the long-term average, usually 1960 to 61 to 90. And then each of these anomalies was plotted as a point on this. And you get this black mass of points. And the important point is the range. It's from -2 degrees to 2 degrees. And then you take the average of this, and you get this. And normally, given the noise in the system, you would say that essentially this averaged to essentially 0. That's not very exciting, but it's easy to make it exciting. You change the scale. So now, instead of it being 2 degrees, it's 0.2 to -0.2 to 0.2. Now it looks significant. You can make it look significant by stretching, but one should remember in all of this that the opportunities to adjust the results are also significant on the stretch scale, especially if one really cares about a few tenths of a degree. Why one should care about this is another question. I mean, this is, again, from some years ago. Nothing would change if I took it from yesterday. Actually, it would. Summer is not as good as April to show something changing. But, here you have some interesting things. So for each day, you have this. This is the low for the day, the high for the day. These are in Fahrenheit. And this is the low for the day, the high for the day. The gray is the average low and the average high for the day. And the light gray is from the record-breaking low to the record-breaking high for that day. And so what do you see? You see that, this stuff, the real data is fluctuating about the average bars. The extrema are pretty much the same. They're coming from a scattering of days. They only show the date of the extremum for the last day they show. So here it was 1974 and 1909. I have occasionally used this when speaking to high school students who are taking a meteorology course, because I asked them to look at today's map and tell me what the record-breaking high and record-breaking low will be no matter when they occurred, because here it was 1974 and 1909. And they all can do it pretty well. They do it by looking at the warmest temperature on the map of North America and the coldest temperature. And the record breaker is when the wind brings that temperature over Boston. And then there is this red line here. And all that is, the thickness of that red line represents the range of global mean temperature anomaly over the past century. That's to put it in perspective when people say, I feel global warming. This is again something I've used before just for fun. You've been told that earlier warming was natural, but recent warming was due to man. Okay, so this is global average temperature in 2 half-century periods, which is 1895 to 1946 nature, and which is 1957 to 2008, which is due to us. You can take your guess, but not a heck of a lot to distinguish these two. So is there any use for global and annually average temperature anomaly? And the answer is, it is probably relevant to the response to global forcing, like that due to increasing well-mixed greenhouse gases or solar variations. So in that sense, it would have a use. So for instance, you might want to know how sensitive is the climate to this sort of forcing. But that wouldn't look like most past climate change. That would be something special due to this. And that's the problem. Unfortunately, given a change in the global temperature anomaly, it's not possible to attribute it to global forcing, because most of the time it's a residue of other changes. Thus, it's difficult to use the mean anomaly record to identify whether there is an issue. What I've suggested for a long time is we need an independent evaluation of sensitivity. And that's a somewhat complicated issue, and I'm not going to dwell on it here. But the common measure of sensitivity is the equilibrium response to mean temperature to a doubling of CO2. Almost all observational approaches to this question have led to sensitivities less than about 1 degree centigrade. However, the IPCC, based on model outputs, still offers 3C as the most likely value. You saw one attempt from Howie Hayden to do that, and he got 2 degrees, but that was simply because he used the radiative forcing only from CO2. The IPCC would double that, and so the sensitivity would go down by 2. So even the temperature record is consistent with a much lower sensitivity. Okay, so that's where we stand on this. The issue of global warming is clearly a mess. It has been costly to society. It has the potential to be vastly more costly, and it has certainly been damaging to science. And the question is, how do we get out of this? Well, in the case of eugenics in the US in the early 20th century, the political agenda was immigration. The eugenics movement provided the advocacy base, and the co-opted science was human genetics. The movement achieved the Immigration Restriction Act of 1923, as well as forced sterilization laws in several states. The movement became discredited by the Nazis, though the American consequences survived well into the 60s. In the case of Lysenkoism, it fit Stalin's megalomaniacal insistence on the ability of society to remold nature. Under communism, the state was its own advocacy organization. However, opposition within the Soviet Union actually remained strong during this whole period and was consistently supported by scientists outside the Soviet Union and was eventually able to assert itself after Stalin's death. However, even here, after this assertion, sort of at the end of Khrushchev's period, Khrushchev was a strong supporter of Lysenko. Lysenko and his supporters continued their formal positions, so they didn't lose their livelihood, and that, I think, facilitated ending the dominance of Lysenko, since the advocates were no longer defending their jobs. Okay, global warming differs from the preceding two affairs. First of all, unlike the preceding two, global warming has become a religion. a surprisingly large number of people seem to have concluded that all that gives meaning to their lives is the belief that they are saving the planet by paying attention to their carbon footprint. You know, there's a cute cartoon from the Wall Street Journal. There may, however, be a growing realization, I'd maintain, that this may not add all that much meaning to one's life. But outside the pages of the Wall Street Journal, this has not sunk in, and people with no other source of meaning will defend their religion with jihadist zeal. In contrast to Lysenkoism, global warming has a global constituency and has successfully co-opted almost all of institutional science. However, there are cracks. The cracks in the scientific claims for alarming warming are, I think, becoming much harder for the supporters to defend. Despite official whitewashes, ClimateGate was a clear manifestation of pathology. Opposition to alarm is having some impact among certain groups, including physicists, with a rump group that is demanding that they reconsider their position. Official reports from several countries, including, surprisingly, Norway and India, have taken a distinctly unalarming position. And even Ralph Cicerone, who's president of our National Academy of Sciences and was elected to the Academy through the temporary nominating group for the global environment, has publicly eschewed climate catastrophism. So I think they're setting the pace for their retreat, hopefully. Human society, like the climate system, has many degrees of freedom. The previous cases lasted 20 to 30 years. The global warming issue is approaching 30 years since its American rollout in 1988, though the issue did begin earlier. Perhaps such issues have a natural lifetime and come to an end with whatever degrees of freedom society affords. Let's hope so. Thank you. And there's time for questions.
Dr. Lindzen, thank you again for your usual insightful observations. One suggestion I would have that I find has some merit for fixing of this situation is, to the public, they have no discernment between science and scientists. They're synonymous. So in other words, if a report is generated by 5 PhD people, the public believes that that is a scientific report, and that often is not the case. And I think it behooves us that who understand science to make a parallel to say, just like all priests aren't doing the right thing, or all lawyers aren't law-abiding citizens, there's a lot of scientists that are off the reservation. And just because a report is written by scientists doesn't mean it is scientific. So to me, that's an important distinction. And one other thing is you might want to talk about PNS. That's another intrusion that's undermining traditional, genuine science, in my opinion.
PNS?
Post-normal science,
Oh.
PNS. Well, it's another attempt to undermine what real science is all about.
There's no question about that. I don't know what you do about it. I mean, I don't see how this issue will not, at least temporarily, discredit all of science. And I don't know how you do this in public without having a very unseemly pissing match. Okay.
Professor Lindzen, thank you so much for your great work there at the institution of MIT. It's so important to have your voice of reason coming out of MIT and the Boston establishment there. I want to ask you, is it possible today for a PhD candidate or someone who's trying to get tenure at one of these institutions to be critical of the global warming alarmism?
Well, let me be careful in how I say it. Not openly. I don't think a young person today could make a career if he were openly critical of global warming. What happens instead is you have what I would call Moranos, people who are secret skeptics. So you'll have papers written, I could cite a few. Jerry Rowe had a paper on the Milankovitch theory of ice ages. He includes a remark in it, though he says that even though he does not refer to the role of CO2, he wishes the reader to understand he's not ruling it out. You have a paper by Horvath and Soden where they confirmed the iris effect that I had worked on 12 years ago. But they have to add a paragraph, and I'm sure the reviewers insisted on it, that said, although this would appear to confirm it, we wish to refer the reader to the articles that criticize this and point out that it's wrong. So, the literature is full of this stuff. It's also the case you cannot have a job at a university and get promoted if you don't bring in money. And so your grant application certainly can't say you want to check whether global warming is real or not. Instead, you have these things that I pointed to in sociology and psychology, which are sort of gibberish things, but they endorse it. As a practical matter for my colleagues, if I have a student or someone, what I've discovered is, for instance, I have one colleague now who is a postdoc with me from South Korea. They apparently don't mind objections to global warming, and they have their own satellite program, and they want to go forward. And so there it seems to be safe. I have another former student who I still work with in Chile. He cannot come out. Chile is much more politically correct. I have another student who's visiting from France. He has no intention of staying in the field, so he can do anything. Okay.
Thank you for pointing out so elegantly the fact that fluctuations from the mean are usually in human affairs much more important than fluctuations of the mean. Some of the current absurdities, for example, are the alarmists pointing out that sea levels might rise by 1 foot in 30 years when the average tide in every coastal city is 3, 5, 7, 9 feet every day. In the medical point of view, the fluctuations in the daily temperature are much more important for human health than the change in the average temperature. Whether it goes up or down by 1/10 of a degree does not matter one bit. The fluctuations on a daily basis matter in two senses. The death rate from cold in the winter is about 9 times the increased death rate from heat in the summer, which is not widely appreciated. And therefore, the EPA, by throwing away all the data on cold in the winter and just counting the death rate from heat in the summer, has allowed CO2 to be classified as a pollutant because it harms human health under the Clean Air Act. Another new effect, which you may not be aware of, is that what you showed, the diurnal temperature range, the difference between the high and the low every day, is a stress on the circulatory system, and the rate of heart attacks depends significantly on the diurnal temperature range. The bigger the change between heat in the day and cold at night, the more heart attacks there are. What's more paradoxical and perhaps interesting is that if CO2 has an effect on the climate, the warming that it may cause occurs at night, which decreases the diurnal temperature range by making it warmer at night when it would normally be colder, and that changes the rate of heart attacks to the good. So in terms of human health, a little bit of CO2 is a good thing, and a lot might be even a better thing.
But probably not a big factor.
Oh, it's surprising. It's
Really?
Yeah, it's 3 or 4 or 5%.
So you're
change in
saying
the
a
death
few
rate.
tenths of a degree?
Pardon?
We're talking
No,
about
no,
a few.
you're talking about the average. What I'm saying, though, is that the
Yeah,
world-
yeah, but the deviations from the average are unrelated to CO2.
So, yeah. But what I'm saying is that the claim that CO2 is harmful
Oh, yeah, yeah.
is false on two counts in terms of the cooling, the decrease of cooling in winter.
But remember,
and in
the
terms
whole
of-
system is based on inversion. You know, in other words, the residue is caused by the main effect, but you call it the cause. You know, if it has nothing to do with logic. That's the problem.
I remember reading that the worldwide global average temperature was kind of nonsense because in the old days they had like a lot of monitoring stations in Siberia that were abandoned, and so those are no longer part of the average anymore, and add a few more here and a few here that was kind of, but it was all lumped in together as if it were stable and actually reading the same points over a period of time.
Yeah, what I'm trying to do is wean you from the obsession with that. When you're dealing with the residue, all those things matter because you're obsessing on 1/10 of a degree in something which has an uncertainty of 3 or 4/10 of a degree. So you can argue, was this a little higher, was this a little lower? Then the statisticians can come in and say, you know, when you took this curve and you stretched it, it has a certain significance. And the argument goes on and on and on. And all I'm saying is, this is not what the climate is about. It's kind of the magician's trick of having you watch one thing while another thing is going on.
Yeah, just to sort of recite the conversation we had outside, trying to wean us from small things, to compare the types of external forcing with Milankovitch, which, properly adjusted for the first derivative, does a pretty good job of explaining
Does a super
glacial,
job.
the interglacial period, significant climate change. And if you take a look at the watts per meter squared or whatever is a suitable from a physics standpoint, the phenomenon there versus we're talking about 1 or 2 watts per meter squared. So, I mean, I'm completely lost in these very small measurements, and that's what is so profoundly distressing, is that people get upset or project dramatic effects from what seems like a very small effect here.
Yeah, we agree completely on that. I mean, what this gentleman is referring to is the following. The cycles of ice ages, you know, big changes in climate every 100,000 years. For 90,000 years, we're under a couple of kilometers of ice, and then we're free of ice like we are now. And this involves a quantity which is the change in solar insolation north of about 50 degrees in summer. Why in summer? Because what determines whether a glacier grows or not is not the snow in winter. That'll always occur. It's how much of it is melted in the summer. And so if you have low insolation in polar regions in summer, some of the snow survives, and then it accumulates the next winter, and over a few thousand years becomes very deep. This quantity, the summer insolation over the Arctic, varies by over 100 watts per meter squared, as much as 200. When one speaks of a doubling of CO2, one is speaking maybe of 3.5 watts per meter squared. If one looks at the orbital changes that cause Milankovitch, if you average them over a year, they're nothing. But that isn't what drove the ice. And so we throw out the baby and everything else with the dishwasher water to fit it into the paradigm of one variable global mean versus one variable global mean temperature. It sets back the science decades, if not generations. Yeah?
Just a personal question. I was really surprised on your first slide. You're an emeritus. Is this going to change your activities?
I hope so.
I'll be quick too. Would it be a valid analogy to say that your point is that a man with his foot in one foot, in the fire and one in the ice, and the global warmers are saying as long as his temperature is 98.6 right now, but we've got to man the battlements to prevent it from going up to 99.
I think that's a very good analogy. No, I mean, with body temperature also, I mean, if you think about it a little, if our body temperature did not fluctuate on short time periods, it could not be stable on longer time periods. If a building is rigid, it collapses. It has to sway to be stable. We seem to have forgotten that and treated change as bad as opposed to an indication of stability. Okay. Thank you.